Assalamu alaikum. This video will discuss Documents 2 of Chapter 5, Autosomal Diseases. In the previous videos, you have learned about the autosomal genes and sex-linked genes. And you have learned how to prove a gene to be sex-linked depending on pedigree analysis. Unlike sex-linked genes, autosomal genes are equally inherited by males and females. Thus, the transmission of autosomal diseases to children is the same, whether the mother is the one affected by the autosomal disease or the father is the affected parent. Some autosomal diseases that you will learn about in this document are cystic fibrosis, which is a severe disease caused by a recessive mutant allele of a gene located on chromosome number 7. Cystic fibrosis is characterized by the excessive secretion of mucus by mucus glands, leading to both respiratory and digestive problems. Another autosomal disease is Huntington's chorea, caused by a dominant mutant allele of a gene carried on chromosome number 4. However, it only appears in affected individuals between the age of 30 to 50 years old. Huntington's chorea is characterized by lesions of certain neurons of the central nervous system, which causes uncontrolled, incoherent movements, accompanied with psychological troubles. As in the previous video, you will not be learning about the progression of such diseases, but instead you will logically analyze a pedigree to prove the location of the genes responsible for such autosomal diseases. Here is the strategy you should follow to prove a gene to be located on an autosomal chromosome. First, deny that the gene is located on the non-homologous part of X chromosome. Second, deny that the gene is located on the non-homologous part of Y chromosome. Third, deny that the gene is located on the homologous part of X and Y chromosomes. This way, there is only one possible location left, which is the autosomal chromosome. Let's use the pedigree of a family with some members affected by the recessive disease cystic fibrosis. To prove that the gene responsible for the disease is autosomal, let's follow the strategy step by step. To deny that the gene is located on the non-homologous part of X, search for an affected girl with a healthy father. For example, female 3 of the second generation is affected. If the gene was carried by the non-homologous part of X, given that the allele for the disease is recessive, the genotype of this female would be XCXC, which means that she must have inherited an X with the recessive allele from each parent. But this way, her father would be of genotype XCY and will be affected, which is not the case. Thus, the allele could not possibly be carried on the non-homologous part of X. Now, to deny that the gene is on the non-homologous part of Y chromosome, search for an affected girl or search for an affected boy with a healthy father. In this pedigree, both proofs are available. If the allele for cystic fibrosis was carried by the non-homologous part of Y, then it's not possible for females to be affected by this disease, knowing that they only have 2 X chromosomes. Having affected girls in the pedigree certainly assures that the gene is not on the non-homologous part of Y. Besides, if the gene was on the non-homologous part of Y, then every affected male will have an affected father, from whom he inherits the YC chromosome. Is this the case for this pedigree? Sure not. Check the affected males in the pedigree. All of them have healthy fathers. Using one of these two proofs is enough to say that the gene for cystic fibrosis is not linked to the non-homologous part of Y chromosome. One more step left to finish your proof. Deny that the gene is on the homologous part of X and Y. To do this, search for affected siblings, male and female, with a healthy father. Consider the affected siblings 3 and 6 of the second generation. If the gene for cystic fibrosis was on the homologous part of X and Y, then the genotype of the female 3 would be XCXC, and the genotype of her brother, 6, would be XCYC. In such case, the genotype of their father would be XCYC, and he will be affected, but this is not the case. Thus, the gene for cystic fibrosis is not linked to the homologous part of X and Y. So the gene for this disease is located on an autosomal chromosome. Now, when it comes to a dominant autosomal disease, like Huntington, shown in this pedigree, you will follow the same strategy as well, only the examples you take from the pedigree will be different. In case of a dominant disease, to deny that the gene is linked to the non-homologous part of X, search for an affected father with healthy girls. Since the affected father will have the genotype XHY, the father will certainly pass XH to all his daughters that will be affected. But in this pedigree, the healthy female 3 of the third generation has an affected father, which suggests that the gene is not located on the non-homologous part of X. To deny that the gene for Huntington is located on the non-homologous part of Y, search for healthy boys with affected fathers, because an affected father will certainly inherit the YH to his boys. Or search for an affected girl, because it's impossible for a girl with two X chromosomes to be affected with a disease linked to the Y chromosome. Now, to deny that the gene is located on the homologous part of X and Y, search for a healthy sibling, a brother and a sister with an affected father. To be healthy, the female 3 of the third generation will have the genotype XNXN, given that the normal allele is the recessive allele in this case, while her healthy brother will have the genotype XNYN. In such case, the genotype of their father would be XNYN, and he will be healthy as well. But the pedigree shows he is in fact affected with the disease, which suggests that the allele for Huntington is not located on the homologous part of X and Y. Thus, the gene for Huntington's is an autosomal gene. And so, every time you want to logically determine the chromosomal location of an autosomal gene from a pedigree analysis, remember these 3 steps. Assalamu alaikum.